survival.
Spherical geocentric position,
Sure,
right?
sure. But my point is that the fact that people misrepresent.
Activity. That's fine. I mean, like for I don't think I don't think it's that kind of thing that's bringing people over to the flat Earth side.
No, it is. What I'm saying is, so if you Google it, the mainstream pop sci articles will tell you things like retrograde prove that the Earth moves around the sun, and parallax and aberration. And all they have if they research and find out that's not true, they're like, why is the mainstream lying? Another big part of it is the mainstream flat Earth debunk videos lied and got caught lying. So it
Mainstream
isn't,
flat Earth debunk videos.
yeah, National
I don't
Geographic
know. I
was a,
haven't seen them. I can't comment on that.
yeah, and I'm not
All
obviously
I've
you
seen,
didn't
I
lie,
saw
but
the
you understand
Netflix
the
thing a while ago. I saw the Netflix thing a while ago, but I don't really remember much about it.
that was a hit piece. They lied in that too, but I'm saying you get the logic, right? Like if they go and they would think, why would you have to lie if flat Earth's so stupid? So like Stephen Hawking did a documentary. It was a Stephen Hawking documentary, and they said that they looked at a helicopter across a lake, and the bottom of it was hidden because the Earth was curving, and they proved it. Well, you can actually do analysis and prove that the video was faked. They actually put the helicopter in the video, and you can prove it because the birds fly across the screen same time, water is the same thing, blah blah blah, provably fake. And then National Geographic
Is
did
this
one.
like provably fake in the same way that like the ISS footage is?
No. It's provably fake. Like I've never even heard a globe or any globe earther say anything but agree that it's definitely was doctored and fake. Same with the National
Yeah,
Geographic
I
one.
haven't seen this, so I don't know. I haven't seen any of these.
And that's cool. I'm just saying, like the National Geographic one, they put a boat out with a sign with like different color lines on it, and then they say, "Oh, look, the bottom line's missing. That can only be explained with the curve of the Earth." When in fact, you can see at the beginning of the video there wasn't an additional line at the bottom, so it was like deceptive, and the horizon's behind the boat anyway. All that to say, that doesn't prove the Earth is flat or anything, but you understand my logic. If they see that these mainstream things that are shown to millions of people are lying, they're like, why do they have to lie? And then they go look at NASA, they do see fakery. Like they've cut to models midstream before. Literally, they've been cutting to a model before. And so when they hear other people defending the globe act like, oh my God, you're insane to even suggest NASA may be faking things in space, they're like, okay, well, you guys are lying. So that's the reason it's growing, bro. That's the actual answer. I just want to throw it out there. I think you're smart enough to know it's not just because people dislike Jewish people or something, right?
No, so I don't think that's why people become flat earthers, but I think that those people are particularly attracted to it for whatever reason. I don't know why, but there is a large contingent of people who are flat earthers and also anti-Semites.
Yeah,
I don't know why,
I've even been called
but it is certainly the
anti-Semite
case,
before.
and I've met a lot of them.
Sure, that word gets thrown around a lot. Like I've been called that before.
Okay, so you know Caleb, right?
Yes, yeah.
When Caleb found out I was Jewish, he just spammed me with like Hitler quotes in Discord.
Yeah, that's extra, bro. I don't think that's cool, but
So like that's the kind of thing I'm talking about.
sure. But I'm saying that's not particularly popular. But if anyone questions anything regarding any of those topics, they're immediately shut down and called that word. Like, for example, I've said, my daughter has a Hebrew name. I believe in Hebrew cosmology, bro. Right? Like, I'm far from like anti-Semitic, whatever that means, because that's a Mediterranean language, and I mean, I don't think Palestinians are anti-Semitic, right? I think it's a goofy word.
Anti-Semitic was invented by a German guy to relabel Judenhass, which is Jew hatred.
But it is a goofy. It's a goofy word when you look at.
It was a word that a German. It was a word that a German guy who hated Jews invented.
Sure.
Specifically to replace Judenhass,
well, then it was
which means Jew hatred.
Then it's a terrible choice of words because there are some things I disagree with, like certain, maybe you would call it extremist interpretations of Judaism that is effectively ethnic supremacy. It's like there's physical superiority because God chose my ethnicity, so I'm actually physically superior and ethnically superior to all other races. I was chosen by God, and then eventually I'll have a Messiah.
Yeah, that's cringe.
So but I've said like I disavow ethnic supremacy like that, and then people have responded by calling me anti-Semitic, which is an accusation of racism, right? You see how goofy that is? So I don't like the word being thrown around so much. If Caleb threw all kinds of crazy stuff at you, right? I'm obviously not defending that, but anyway, I will say that I don't think that flat earthers hate Jewish people. I think that's not nearly as popular as you're.
The only reason I brought that up is because So I do a lot. I do a lot of like, I talk to young Earth creationists a lot. I talk to a lot of conspiracy types a lot. The kind where I get the most just blatant, like that kind of stuff. And again, I don't know why, but it's the flat Earth community. It's where I see it the most.
I'm sure there is definitely an overlap because there are some things about the mid 20th century and certain things that, you're not even allowed to discuss. And if you tell a group of people that they're not allowed to discuss something, it actually creates extremism, right? Which I think is like the worst thing you could ever do. And whether or not you agree with what they think, I mean, telling them they can't talk about it is it's the exact opposite of how you would stop people from talking about it. It makes them more extreme. I think there are people that research things below the surface level of mainstream narratives. And yeah, there's probably an overlap there because there is some truth to the fact we've been misled about both of the world wars. There's a lot of stuff. There's a lot of documentation that people, you have to search to find it, blah, blah, blah. Obviously, don't take that to mean that I'm I'm a fan of Hitler or something, right? It's obviously not the case, but history is written by the victor, right? So anyway, that's the overlap. I don't dispute there's some overlap, but I just think the word is thrown around very loosely to shut down.
I'm sure it is. I know that people overuse words like racism and stuff like that. I tend to reserve certain words for certain explicit actions. But that's neither here nor there.
Okay, sure.
Anyway, do you know what the name of the Stephen Hawking thing is? Because I looked it up on YouTube and I couldn't find it.
I'll have to find the name of it. I'll message Jaron. Yeah, but I just know it's here. I'll message him right now. But yeah, it's pretty funny, man. They did a thing in National Geographic too. You can obviously say that if they did fake it, that's just like a bad look, right? I mean, they may
it'd be really
like,
sus.
they'll think like, the Earth's a ball and fake it. That's possible too. It doesn't mean they know the Earth's flat and they fake, but it is it's a terrible idea because if you think flat Earth's wrong, that's the exact opposite of what you would want to do. But yeah, I'm looking up. I think he actually has a TikTok video on it. Jaron does. Stephen Hawking documentary.
Oh, somebody says I should Google. Oh, it was National Geographic. Oh, okay, so I Googled Hawking.
I think
National Geographic helicopter globe test.
They're both National Geographic. One of them is like a Stephen Hawking documentary, I think. But anyway, and speaking of, and this is the other thing that makes flat Earth, it's not going to go anywhere. I can assure you because. I have Stephen Hawking's book over here, Stubbornly Persistent Illusion, right? And it's practically a forward of Einstein's works, and he just writes forward in it. But like, it's admitted by even Hawking, right, that like you can't actually disprove that the Earth's in the center of the universe, and a lot of the evidence suggests that it is. I choose not to believe that on grounds of modesty. So that's
so look. If you were to come on here and try to defend like round Earth geocentrism, I'd be like, weird, but okay. If you understand general relativity properly, then that's fine, I guess. But that's not what you're defending. That's not the position you hold, right?
No,
you don't hold round Earth geocentrism as a position.
No, I don't. But I'm just saying that is a major part of it. This conversation is broken up into two primary portions: is the Earth moving and is it spherical? And I'm just explaining that everyone that defends the globe Earth and kind of pretends all flat earthers are stupid, they defend the heliocentric model as if it's as definitively proven as the sky is blue, and that is just not the case. It's not even close to the case.
Well, for what it's worth, the heliocentric model is true. So is the round Earth geocentric model. They're both true.
Well, that's what you think,
right?
That's
the point. Well, at least that's like it is. If somebody believes that the Earth is round, it is not incorrect to say that the heliocentric model is true.
Well, I'm just saying that
because in one coordinate frame, that is the case.
Okay, but the conversation isn't just about the kinematic coordinate, the coordinate system. Like, yeah, that's part of it, and yeah, relativity says it can go either way. But it's like, well, if the Earth's not in the center, we have to explain why it looks like we are. And so then we came up with accelerative expansion. So we have the Hubble constant. Now we have the cosmological constant. No one can actually explain exactly what that energy mechanism is. There's a lot of things that.
I'm actually writing a paper about it as we speak. Not literally as we speak, but
really
over the last month.
With the Hubble constant?
No, the cosmological constant, yeah.
Dark energy, yeah. So they moved the goalpost a lot to save heliocentrism, right? So when someone goes and looks at it and Wikipedia says all Michelson-Morley did was debunk the ether, then someone goes and reads Einstein's paper themselves, and he says, Michelson-Morley brought us into great embarrassment. And if it wasn't for that, no one would have even considered relativity as a halfway redemption. And then he goes into explicit detail that special relativity, the first path that led him to that was Michelson-Morley, and that the result was very puzzling. And then they changed the definition of orbit. It effectively debunked Newtonian orbit. That's the real situation. That's what actually happened. It flipped all physics on its head, but the mainstream will tell you it just disproved the ether, and that's all it did. And it had nothing to do with the motion of the Earth, and relativity had nothing to do with it. That's not true. That's not true. There's a philosophical bias to heliocentrism. It's the Copernican principle, and that's cool, but it's presented as like definitive scientific fact, and that's not the case. So that the motion part of it is, I would say, super easy to debate. But the flat part of it, what ends up happening is people just want to ask you how everything works. So like, oh, well then, what's a star? Well, then what's the sun? I mean, I can replicate the arc and the path of the sun and the sun disappearing from the bottom up right here in my room. There are a lot of things people think are impossible if flat Earth are not, but that's not really how this works, man. Like we don't have to know how everything works for the globe to not be true. It's very intelligent people.
I mean, but you do have to present evidence. So either, I mean, two ways this, right? You could either present a better model, which you're saying that you don't have, fine. But if you can't present a better model, then you have to be able to contest the majority of the evidence in favor of the other model.
Sure.
Right.
Well, yeah. Well, obviously,
and that's the issue.
You can falsify a model, and it's just wrong, even if you don't have a good replacement. I actually think I do have a better model. By the way.
That's fine. But where's the falsification of the globe, right?
Yeah. It would come down to the R value. So like there are many falsifications of the R value. Like we saw Canigou. You can go watch.
I'm familiar with Canigou. I've even just punched into Walter Bisson's thing, and it's fine.
No. See, that's what I'm saying. That's not how this works. Well, like twice a year, the sun sets behind Canigou, and you can see it from like 163, 170 miles away, 1,000 feet up, and we know it's going to be there because of the angle the sun sets. You don't see Canigou the whole day, though. It's not like it's refracted up and you can see it. You can't see it until the sun sets behind it. People can travel from around the world with certainty that the sun's going to set behind Canigou and you can see it exactly where it would be if the Earth were flat.
My understanding as to why that happens, and I could be wrong, but my understanding as to why that happens is because it is very far away and it doesn't emit its own light source. So if you were going to see it, it would have to be effectively you'd have to light it up somehow and intensely brightly. And because it's so far away, you get inverse square law losses and you get extinction level losses. On the other hand, when the sun is behind it, now you're seeing the sun, and the way you're seeing Canigou is via its shadow, which is the sun behind it is significantly brighter. So it's not like Canigou has to be bright and emit a ton of light.
Yes, that is the globe position. Yeah, like that. Obviously, the light just reflects off of the mountain, and because of light attenuation, right? You can't see it until you get the silhouette. But for one, then I'm glad that we can all agree that there is light attenuation, and that's based on turbulence and density and stuff like that. I would get the light source is obviously going to attenuate less, but it is just a baseless assertion that the light from the sun wouldn't attenuate. Of course it would. It absolutely would.
No, it would attenuate. It just starts out much brighter, right?
Yeah, but you know that a bunch of globe earthers will actually say that you would, if the Earth was flat, you'd see the sun from across the entire world, and the whole Earth would be daytime at the same time. And this is just patently wrong. The light would attenuate. We videoed it disappearing above the horizon multiple times.
Yeah, so I did the math on this actually somewhat recently in my Discord, and I can go pull it up. But you can just like do normal attenuation calculations. It was a bit messy actually, but it worked out to be to the idea that it depends on how high the sun is above the Earth, above the flat Earth. But if the sun is quite high, then you should be able to see it from thousands of miles away. Like thousands of miles, like on the other side of the Earth kind of thing. If it's quite low, then you can see less of it because then more of the light is passing through the denser part of the atmosphere. But then you have a problem with a sun that's low in the sky, right?
Well,
which is a problem for other reasons.
A lot of things to this, right? It's like, well, what is the sun? How big is it? And how high is it? Are we seeing the actual position or the apparent position? I'm very honest about flat Earth, despite the narratives about me. I'm be the first one to tell you that the only way that flat Earth is possible with what we see with the sun is that we're seeing an apparent position of the sun. That's just based on the actual trajectory.
So do you think that the sun is above the firmament?
I think there's layers to basically a torus field.
You mean like the magnetic field created by like a dipole?
Yep. Yep, and I would say that the North Pole's in the sky, South Pole's down below us. We see the top half of it, and there may be a solid container, and that kind of molds it or something to that effect. But anyway, the sun would be within layers of it. So there's actually a couple different ways this could. If the sun's above a certain layer but below another layer, for example, you could actually see an apparent position that's basically a reflection.
Is there like a different optical density, like refractive index between these two layers?
Well, yeah, but yeah, the medium that's below it would be basically causing an optical displacement. So yes, there would
So
be
I mean, the medium that's below it is air, right?
I don't know.
Because
See,
that's like what we breathe.
well, there's definitely air below it, right? But is there something else below it, or is there something that's containing it? Like, is there I mean, semi-permeable layers, something that acts like a supercell? I don't know. Even like high levels of plasma, but there could be layers. The sun is within one of those layers. As you look at it from
So
the ground,
there's
you're going to
a
see displacement.
there's a neat thing that I did a while ago, and I did it on live, but I may have closed out of it. But I'll just show it to you, and you can play around with it on your free time if you want. Because it's a really neat way that you can actually just kind of test these things. Let me turn around my screen. Da-da-da-da-da. So it's just a ray optic simulator. And I can, if you want the link, you can.
I think I've used
tell you about it. And so one thing that I've done before is you can just make a half plane. So this is your Earth, and then you can draw where is it polygon. Sorry, I'm just trying to. Here we go, polygon circular art, and I'm just going to draw a dome. It's an approximation, but it's close enough. Something like this. We're only going to care about what's going on the inside anyway. We can adjust, we can adjust the index of refraction. We can make it glass or make it whatever material you want. And then we can just put a light source, like a point source somewhere. Increase the, we can increase the ray density. We can make it so you can see the apparent objects from a given viewer, and it'll just tell you where it'll appear to be. So the orange dot is where it appears to be. And so, like, if the actual source is here,
well. Right.
If the actual source is there, then you'll see that the apparent source is basically in the same place as the orange source. Now, if I get close to the edge, because you have some issues like this because I didn't make a perfect circle, but you can understand where it would appear to be. Right, and if I move it around, the apparent source moves with the actual source. So I mean, like,
it does move with it, yeah. But I will.
So I mean, like, it's close to it.
Well, I just did it
but
in my room.
This is
it's not. I just took the phone flashlight directly over this little dome, and I kept it at the same height. But what you see in the dome is an arc of an apparent position that is displaced, and if you move the flashlight at a slight angle, it actually displaces even more. If it's in a slightly curved path, and it would set just off of west, which is what we see. So I can literally replicate it. I would say there's a container, and we have an equidistant limit to our view that it basically is like a dome. And you agree that even your model says that, right? That there's the edge of the visible universe, and it's equidistant in each direction. You guys, of course, just claim it's way further. So I think that even that would cause that.
What I'm saying is that what I would suggest is just play around with like a tool like this, and you can adjust you can put layers, you can adjust the index of refraction, do whatever you want to see if you can make it all work out, right?
Yeah, sure.
It's a super neat tool.
But just so you know, like, I'm just saying, like, I am looking into the sun. I think that I can basically map out the whole Earth, like the 60 nautical miles per degree. It's a logarithmic function. You can map all that out, celestial navigation, like the position of the sun, how it sets, all of that. And that does take a lot of work. And any honest person will be like, wow, well, we had hundreds of years, billions of dollars, and millions of people doing it for us and handing it to us to like try to gaslight a flat earther community that's like 5 years old for not having come up with extensive, in-depth, models about every single square inch of the universe is pretty disingenuous in my opinion. But this is the way flat earthers look at it. The falsification of the globe is independent of replacing it, and that Canagoo observation in and of itself, I would say, falsifies the globe, bro. You can go anytime you want.
If it falsifies it, then No, but the light around shadows do.
Right. So then,
So
as it's
effectively, shadows do refract.
okay, but so now we're saying that the actual sun is what's being refracted up. It's the sun itself because it's the sun being blocked.
Yeah, of course.
Right. Okay. So now we have to look into the astronomical and terrestrial refraction variables. They're different in your model, like they're different values. And so then it's like, okay, well, then we're going to have to make the claim well, how much was the mountain itself lifted up? Right. And we never see it, but we can just basically assert, well, coincidentally, the light always attenuates from the mountain when the sun sets behind it. And then the light would fill back in once it loops
What
around
do you
it.
mean fill back in?
As the light is coming around the Earth, it's going to continue to diverge out. So if part of it's being
Yeah.
blocked, now you're going to come back over the curve of the Earth. That sun's going to start filling out in front of the silhouette.
I mean, when I've looked at the Canigou silhouette, how do you spell it? I can never remember. Is it CANIGOU?
Yeah, maybe, yeah.
Uh,
I can't remember if it's I or not, but something like that.
It's CANIGO. So I mean, let me see if I can pull up a silhouette from
You agree it's pretty convenient
France.
that the astronomical refraction just so happens to match the flat Earth prediction, which is that you would see it on that specific day 2 times a year, right? Like,
no, I don't think that's really convenient.
Well, it would have to be standard refraction to even be logical.
And for what it's, by the way, for what it's worth, like the refraction that you're seeing, like it's quite obviously distorted, right?
Slightly.
I mean, like I just pulled up a picture, but like it's very.
Depends on what picture.
Like that's pretty distorted.
Yeah, I don't know anything.
Right, like there's light underneath too, right? So there's obviously some distortion happening, right?
Or those are maybe clouds with light reflecting, but I don't know anything about this picture. There's a video of the sun just setting behind it. It's a very crisp silhouette. You see it all the way down to the water, right? I can send it to you or whatever. But anyway, my point is that we're gonna have to say this is a bunch of it's like assumptions the globe proponents seem to think we should just grant them, and I don't operate that way. Like, will you give me an equation?
But look, if you want to falsify something, you can't just say, isn't it convenient that this matches? Because falsifying something basically means you work within the model that somebody is giving, and then you find a contradiction. But if in that model there are these things that you don't believe, well, tough shit. If you want to falsify it, you have to show that within the model you get a contradiction.
That's what I'm saying. The model is, of course, a sphere with a certain size, so it has a certain geometric location of the horizon. I get you.
But it also has refraction. It has other atmospheric effects, extinction rates. All of these things are built into it, right?
And so they're telling you to understand what's happened to flat earthers. First, we were told we know exactly where the curve of the Earth is. You can go see it. Boats disappear behind it. Now the new globe Earth argument was literally revised in like 2020. Oh, you never see the actual curve of the Earth. I understand the logic of it. My point is that flat earthers have been here watching the goalpost move of this home run slam dunk model that we've known for thousands of years, and it's pretty telling that just a small group of people can challenge it. And now the whole entire model is being updated as we speak, and that is what's happening. But with the Canigou,
I think so. The thing is you have a lot of people who. And here I am gonna bash my own side. You have a lot of people who come on and they're like, yeah, I was taught that the earth is round. I went to high school. Maybe I have a civil engineering degree or something, and I took one course in physics or something like that. And they claim that they have all the answers to this, and they don't, because some of this stuff, like geophysics, can be kind of complicated. And so you have a bunch of people who don't know what they're talking about, or at least not particularly well, badly defending the globe.
Absolutely, yeah. Same thing happens with flat earthers, obviously, right? So, I mean,
yeah. So all I'm saying is that, like, I don't know if it's proper to say that, like, oh, the model's changing. It perhaps is probably more likely that the people that were talking about this 5 or 10 years ago, like the randos on YouTube who have like biology, like Professor Dave, right? He has a biology degree or something like that. He doesn't know what he's talking about. He reads stuff on Wikipedia, and then But
we're talking about mainstream scientific communicators like Neil deGrasse Tyson, and now obviously you can have your opinion about that guy, but I mean he is allegedly an expert, and he's what's shown to the masses. And like we were told, even with like a Big Think article, you got Michelle Thaler from NASA, you got all these people. dude, when the boat goes behind the horizon, that's the curve of the Earth that's blocking it. We see like, no, that water line
On
moves.
average, that's correct.
Well, it changed. Yeah, because actually, and this is very interesting. The actual resolution limit of the eye can basically be reverse engineered into a spherical R value. And we've shown this happened in the 1850s. So it would be roughly around the same, like the general resolution limit based on your aperture. And it does change based on your optics, and it does change based on conditions. It isn't proof either way. It's just one side's claiming there's a curve of the Earth there, an actual geometric horizon, but that we can never see it. And the burden has been flipped around to the people saying, well, prove it. And like,
well, wait a minute. No, you can see it on average, right? That's the whole point. That was the point of what I was just saying.
On average, it's 15.
On average, meaning that if you take data over many days with many different atmospheric conditions, then you will find then the average position will be the geometric horizon.
Well, it'll be on average, it's 15% further than the globe predicts it should be, right? That's called standard refraction.
Yep.
So on average,
and so you can subtract off the air, right? Because we can take the average position of the Earth or the average density of the air. We can subtract off the effect and then figure out where it should be, right?
Well, that's not really how we got the. It would be that sounds good. Like if we went out and just measured the conditions, we're like, okay, here's a lab test that shows the relationship of this refractive index, and that's how much it curves. That's not what happened, though. The geodetic surveying went out, saw the average location. It's roughly 15%. We then took the average conditions and just assumed that those conditions must be causing that average amount of refraction. It hasn't been like validated in a lab with the specific conditions, and also they don't even account for attenuation at all. Turbidity of the like turbulence. And
well, yeah, sure.
Are ignored. Well, these are very big variables.
Well, so I mean, air is pretty much clear. The attenuation of air is something like, at least for, I think it was like 550 nanometers or something, you lose like 0.00008% of your light per meter. So I mean, you do lose a lot, like or you don't lose a lot for the sake of where the horizon is, a few miles. Extinction doesn't play a significant role. The math that I did a while ago showed that something like you lose 90% over like 150 miles or something like that. And if you still have 10% of your light remaining, then you can still definitely see that, right?
Sure, but
unless the thing was dim to begin with.
Whatever percentage it is, you're going to need the output of the light source. You're going to need to know the conditions, and specifically turbulence of the air is a very big thing. Sometimes I went out and made observations all over the U.S. The conditions drastically vary, and the turbulence of the air varies.
Sure, I mean, of course, on messy days in LA, you're not going to be able to see anything, right? Or in New York. But you go out to the Great Plains on a clear day. It's quite nice.
Actually, when you go to when it's dry, like I would love to see longest observations of Africa. We see the sun from seemingly much further away. But anyway, I guess what I'm saying is with the Canada thing and with different observations, flat earthers have gone down on themselves. Like, okay, well, this isn't what the globe predicts. The globe will say it's refraction, and then they use the R value, presuppose it to actually do their equation for the refraction. But that's what's in contention. And I've gone and pulled out a P1000 and an infrared P1000, made observations right beside each other. And with the infrared one, I see further and I see more of the bottom of objects. If I'm seeing the object around the curve.
Do you have a video of that side by side?
Yeah, on my SD card. I think because
that would be certainly interesting. If you're looking at the same object, but you see more of something from the same location, that would be pretty interesting.
Right, because infrared is longer wavelength, less affected by refraction. Right, it's not an insane amount.
Yeah.
But you can.
Well,
tell.
it's attenuated in a different way.
Well, there you go. See, that's the sticky part, right? Is the infrared just cutting through the turbulence and what's causing attenuation?
Yeah.
And is the bottom of the atmos actually just attenuating that light? But if it is, well, now again, the flat earth position has gotten a little bit more validity again because, well, even the objects in the distance are being attenuated where we can't see them. And that's what we say happens, right? Like there's attenuation and then there's obviously resolvability, and whatever information, however close it gets to the resolution angle, that information is coming to you and it's getting closer and closer to the resolution limit. And then whatever information is coming is also being attenuated. So like you have a maximum amount of information coming to you, and then there's a rate that information is being attenuated to you. These are the variables
but there's a problem, right? But there's a problem because attenuation can be dealt with. Like extinction rate can be dealt with by just longer exposure times, and resolution can just be dealt with a larger what's it called? I can't think of the word. Larger lens, basically larger
aperture. Yeah.
Aperture. Thank you. Yeah. So like I did the math at one point. If you have a telescope that's, I think, 11 inches in diameter, you should be able to see, at least resolution-wise, you'd be able to see the Statue of Liberty from England. Now, there'd be attenuation, quite a bit of it. So all you have to do is you just leave the aperture open longer, or leave the shutter open longer, collect a lot of data, and you should see a green smudge.
As long as receivable
if the Earth is flat.
information is getting to you, you would need to know what's the extinction point of
Yeah, so I did the math for that. You would be receiving some, well, you don't believe in photons, but you'd be receiving some small fraction. So you'd have to leave the aperture open, or the shutter open for, minutes to perhaps an hour. But you should be able to collect that information, because it's not like none of it's getting to you. It's just very, very small.
For intents and purposes, I agree with the interpretation of it. But like another thing is I would say we cannot see forever. Okay, and I would say that when we make,
but why not?
Because that's just an insane claim to me. Like, I don't know why we would assume that we could see forever, because all observations show us that we can't see forever, and apparently people think that we can. I get that you can think that, and that it just gets closer and closer to zero or whatever, but I don't think we can see forever. And so that's a huge difference. The globe Earth says you effectively can see forever, and that perspective is Euclidean, and that when we look at the stars, they're so far away that perspective doesn't make them change position, and that they only change position because the Earth curves. A flat Earth position would say you can't see forever, and that just like everything else with it, hallways, planes, street lights, the streets do the same thing because of perspective, or the stars. The globe claims, well, the stars do the same thing that perspective would do, but for a totally different reason. The flat Earth says the stars are changing because of perspective, just like everything else is. Right, where you go 60 nautical miles and it drops in the sky. And then they say, well, because the stars are so far away, we can just treat them as equidistant and effectively infinite for intensive purposes of the math. And so they're not going to change based on perspective.
I mean, but the math does work, though, right? Sure, certainly agree with that.
The math works for both, right? You have the linear relationship of 60 nautical miles per degree on a curved Earth. And then but celestial navigation tells you to only take the measurements between like 15 and 70 degrees. And they say because there's like refraction below that, and it's too hard to get an angle closer to.
Wait, you're talking about for measuring stars?
Yeah.
I'm pretty sure that you're supposed to measure above 15 degrees, because below 15 degrees, it's close to the horizon, so you have a lot of distortion.
Right, that's right, yes.
Which I think you and I both agree that closer to the horizon, things are more distorted, right?
Definitely more distorted, yeah. But 15 degrees seems a bit high. But anyway, what I'm saying is that if it's logarithmic, well, there would basically be a portion that could effectively be treated as linear right in that little sweet spot that they use. And to say if it start dropping below that, well, it could change. It does change. And then it's like, well, it's automatically refracting however much it changes. Or we don't see in Euclidean visual space, perspectives non-Euclidean. That's actually one of the things I brought up in our first debate.
I saw, I should really go because it's past my bedtime. I have to work tomorrow. But just one thing that, take a look at. I don't know if you've seen this. Actually, a flat earther brought this up to me at some point, and I read through it. It's quite interesting. Is this the paper? Yeah, this is the paper. It's just a paper about direct measurement of the curvature of visual space. And their conclusion is basically that vision is spherical up close, it's hyperbolic in the midfield, and it's Euclidean in the far field.
Yes, that is that paper's conclusion, yeah.
They just did the experiment, and that's what they found.
Well, yeah, but
is there reason to think otherwise?
Well, yeah, there are papers that have shown slightly different results. The question is exactly how does it break down? It's non-Euclidean, but exactly how do you map it out? And it's relative to viewing angle, height, aperture, and then distance. And there's a few different papers that say different things. All right, so it's hard to tell. Just that one thing's for sure is that visual space is not Euclidean, but the globe model was built upon Euclidean perspective assumption. And so this is a pretty big point, I guess.
Really? I don't think that was. I don't think that's the case.
Lines to the stars. I think we're seeing their actual position, and it comes down to an angle at a horizontal baseline.
Well, but we don't have to use our eyes for this, right? We can use like a telescope.
Same thing, though. Same thing. It's just any optics are.
No, it's not. It's not, because the reason why our vision is weird is because our eyes are spherical, and we have processing that happens in our brain.
That's perception,
right? But if you can just ray trace, right? You can just ray trace, and that's that doesn't invoke or assume any particular geometry. You can just ray trace.
it does assume a Euclidean perspective, like how we get like sizes in the distance. I will say what you're saying is perception. Yeah, like the claim is that our eyes see a certain way, our brain interprets it a certain way, and then it adds a distortion of curvature to visual space. But the question is perspective itself Euclidean? And like, very advanced robotics have actually had to change their learning models to non-Euclidean perspective. And so it's pretty interesting when actually is needed. I guess here's the conclusion, because I don't want, I know you have to go, but like,
yeah, no, it's fine. We go ahead. I'll give you the last word.
So either the Earth is a plane, and you could use Euclidean geometry to describe it, and then we see in curved visual space, or you flip it around, which is what we did to make the globe, and say, well, we see in Euclidean perspective, Euclidean visual space, and the Earth itself is curving to cause the stars to drop. And if you take that rate, you would basically get the same value as the radius value to the limit of your view. Your celestial limit would be roughly 4,000 mile radius. That's where we got that value, that and the resolution limit. So either it's very possible that they hijacked how we see, assume that curvature is the Earth's curvature. Now all the math is a wash. So now we need to go to tests that are actually going to distinguish between the two. And I think things like, Canigou don't work on the globe. That's my position, of course.
Well, I'm gonna let you go, and I said I would give you the last word, so there you go. Thanks for being here.
Yeah, much.
Have a good one, man.
Later.
To everybody who's watching, thanks for enjoying. Hope it was a good time. Had a lot of trolls today, but it is what it is.